morning or good afternoon, ladies and gentlemen, dear professors. So I will just give you some overview about the last year's works we shared with urban design offices, designers, and research on urban morphology. The aim of the presentation is to give you an overview about what's happening if you try to connect all together the infrastructures, the neighborhood, the buildings, the mobility of the people, and you balance the cost of investment in the infrastructures, the cost of investments of your power generation, and then after the life cycle assessment about how much it costs to run the installation. But, well, first of all, just for the starters, we have a huge problem because since the Athens Charter in 1930, we have built cities that are totally segregated, and there is no connections between the different uses. So this is the legacy of Le Corbusier in China, because in China they tried to go at the maximum of this thinking of the Athens Charter, which is, as you see, super blocks. You have special area dedicated for living, special area dedicated for working, and no connection between. And this is where we are. In China today, they have more than 60 million houses totally empty because nobody goes there. It doesn't work, it doesn't fit, it has no services, and even if you have a transportation, you have 2.5 kilometers between each metro station and no capillarity and no other transportation between. So if you look at where we are in China now, and I use this example because it's really critical to look at, they are down in some cities below the 5,000 inhabitants per square meter, which is really the threshold if you want to design a neighborhood. You need this threshold of 5,000 inhabitants per kilometer square. Otherwise, you have not enough inhabitants to use the services and to make that the different services that you have in your neighborhood will be, in terms of finance, at the equilibrium. So it's clear that we have to think in terms of development, how many inhabitants I have in my neighborhood. It means housing and working, and to keep this in mind that we need this kind of threshold, otherwise it doesn't fit. And of course, if you have a low density infrastructure cities, you increase very much your cost in terms of infrastructures. You have here the average, so the more you have, the less density you have, the higher cost you have. So in terms of thinking about your neighborhood, I know you want to have your neighborhood retrofitted, you have to work on the density, not the density of square meters, but the density of people, which is something different. And really thinking about the balance between your cost in infrastructures, the length on your infrastructures, and the cost of your production and utility that you have to install to serve the different buildings that you will have. So you can see clearly that if you are with a different diagram you have here, I will not detail it, you can see it on the slideshow, but clearly we have this correlation between low density in terms of inhabitants and very high cost in terms of infrastructures for the installation of infrastructures, but also during the use of infrastructures. So it links us to kind of thinking where we worked with a project on the idea that how can we go from the idea of a building and the building components, because we are talking here during the Congress about heating, ventilation, and air conditioning. But so how do we go from the building components that we have at the bottom and the green quality of this building, and then we move to the installation, to the maintenance, to the building operation, building in use, building connected to the neighborhood, and, as I mentioned, the urban morphology. Urban morphology is very simple in a way, but it's very complex and it has its own complexity to solve when you will to work and to manage the complexity, because you have several layers that shape your neighborhood. You have to take care about the people you will put inside your city or neighborhood. Who will come? How do they come? So then it moves to a second layer with the infrastructures in terms of connectivity and mobility. And when you have done that, you have to take care about the land use. How many space you use, where kind of use you put on the space, and what is the quality of the space you are going to use, and balance in terms of artificialization, biodiversity, and so on. Then you have to look at the flows. How the people and goods and energy will flow through this system. Then you have to finalize your land property and regulation, because sometimes it has to change, and then it gives you the building shape. So if we want to go further and speak about the grids, the idea behind of the research that I've participated in is to say, well, we have talking about smart grids, but the grids are not smart by themselves. And people are smart, but grids not so much. So the idea is really to think about morphological systems, then looking at the biomimetism and talking about synergic grids, which are based on the metabolism. So you think about your own metabolism. You are eating something, you are giving energy, you are using the energy to make your brain functioning, and then you have to think the same way. So how we can work in the neighborhood in terms of minimizing the use of energy for simple systems, but also how to maximize the use of energy when I need the people to connect. So this is the same thinking that I take with your own body. Your body is using 20% of the energy for only 2% of your weight, because it's your brain. So if I would be a simple engineer, the first thing I will decrease in your body is the energy consumption of your brain, because it's the highest energy consumption. But if I think in terms of approach, morphologically, I need to opt on the opposite way, to increase at the maximum the energy consumption of your brain, because this is where things happen. And to try to manage all your metabolism in a way that it will maintain your body to make your brain works. So for the neighborhood, it's exactly the same. If you want to have in your system the attractivity to your neighborhood, if you want to speak about the sports area, and if something that we use, for example, in Montreal to rebuild the Olympic Center after the Olympic Winter Game in 1976. So we totally rebuilt the area with this thinking, how to make people come to work, to live closely, and to have sport facilities with ice skating, swimming pools, and also a lot of other activities. So it's really important to manage the energy there and to give the energy where you have the most important activities, and to manage that you will balance the energy between the other systems. And for example, they reuse the heating of a swimming pool to an outsourced machine for the ice skating. So the balance is much more better than if you produce the energy only for one system. So if I go further, you can also go deep to a system where you don't use anymore the alternative current, but you use DC power, and then you can go very deeply in this system. You can storage, you can use then the grid. And I will go with the idea of scale-free complexity. I have no time to explain you the concept, but it's quite easy to understand. It works with mathematics of power laws, scale-free complexity, and then you can balance like in your body, because your body is managed by scale-free complexity approach and the same power laws and the same coefficient of complexity. And you can see that you have the same approach that if we are talking about neuronal networks, trees, blood system, you will think the same thing than if you look at a city. The same dispersion, the same fractality. And we can use exactly the same mathematical approach in the system. And if you do so, you can move from a grid where you just have a power generation, distribution, and consumption to a grid which is adapted to the morphology of a neighborhood, that can work on reuse of the different components of storage, the district storage, and you can use this low energy approach. And in terms of emission reduction, they used it in Rotterdam, and in this case of synergy grid, you can go down to 44% of energy consumption reduction, thanks to such an approach, without any extra investment. On the opposite, with lower investment. So if I go with energy, the idea is exactly the same. We do the same for the building. We can have representation, for example, like in Sydney. We also have to think in terms of life cycle approach. This is something we have started to develop a couple of years ago with our colleagues in Finland, to have on a 50-year base, not to talk anymore about a sum of how much energy and greenhouse gas emission is emitted, but how much is emitted year by year, in order also to give the information to the people in charge of the operation, to share the information with the users. So also we need to turn the city into an intelligent organism. As I said, and the comparison was with your body, so it's clear that we need to think like that. And for that, we are also to work with the components for digitalization. So I just show you one example of what Oracle is doing to how to manage a city, but you can have the same kind of example with Dassault System in Singapore. And clearly, you can't imagine anymore to manage a city without an information system for your neighborhood. So just to finish, I will skip some other slide. The idea of a smart city and a smart neighborhood, you have to first think about your users, who you want to put there, your ecosystem, and how you then, at the end, you design your infrastructures. And you always have to think about your services, what you want to achieve, how you work with the inhabitants, how you will work with the people who will use the facilities, and you can go with that. So it's just to give you an example of the energy potential mapping, but what I wanted to emphasize is this is adapted from the last report from 2013-14 from the group from climate change. And it's clear that if you work only on how to minimize the impact of a building, it's not enough. If you work only how to minimize the transportation, it doesn't fit too. You have to work on every indicators at the same time in order to achieve really an efficient building and compact cities. But I know it's very difficult because usually when you want to work in such a system, politically you can easily act on all the regulation of buildings or designing the building. It's very difficult to act on the economic geography. But here in the case of this retrofit, it's big enough to really work on the economic geography of this part of the city, of this neighborhood. And just to conclude, if you go that way, you will not trying to get zero, because zero is when nothing happens. It's nothing, it's zero. It's not very, it doesn't give some wish to go further. Just, my thinking is more to say, well, let's be more, let's be positive. How can we have a kind of metabolism that will be regenerative, that will create something? So the idea is to move from minimizing the impact to improving the regeneration and improving the life that we are creating. Thank you very much.
Okay.